You've made it past the methods. You know exactly how the study was built. Now comes the section most students think is the easiest to read. The results. Mostly numbers, tables, figures. How hard could that be? Here's the problem. The results section is the most commonly misread section in the entire paper, not because it's complicated, but because it's deceptively simple. Students skim past tables. They glance at the abstract summary number and assume that's the whole story. They almost never notice when a result is quietly missing. The results section has one job: to report what was found, not what it means, not why it happened. That comes later in the discussion. If you find yourself reading interpretation inside the results section, that's worth noticing too. Results should describe, not explain. There are 5 things you read for: the participant flow, the primary outcome, the secondary outcomes, the tables and figures, and what's missing. The first thing you look for is the participant flow. Before any outcome is reported, a well-written results section tells you exactly how many people started, how many were excluded, and how many were analyzed at the end. In an RCT, this is often shown as a flow diagram tracking patients from screening through final analysis. Why does this matter? Because the denominator changes the meaning of every percentage that follows. If a study screens 500 patients but only analyzes 200, you need to know what happened to the other 300. This connects directly to loss to follow-up from the methods episode. The results section is where that number gets applied to every outcome calculation. A rate calculated on 303 patients means something different than the same percentage calculated on 358. And you need to know which denominator is actually being used. The second thing you look for is the primary outcome. Every well-designed study defines before it begins its main outcome. Sometimes one primary outcome, sometimes a small number of pre-specified primary outcomes. This is the result the entire sample size and study design were built around. Find it first. It's usually stated using the exact same language as the aim in the introduction. Why does this matter? Papers often report many numbers, but they were only statistically powered to detect a difference in the primary one. A secondary finding that happens to reach significance in a study not designed to test it is weaker evidence than the primary outcome the study was actually built to answer. Always identify which result is the primary outcome and read it with full attention. Everything else is secondary by comparison. The third thing you look for is the secondary outcomes. These are additional measurements collected alongside the primary outcome, useful for context and for generating future hypotheses, but not what the study was built to prove. They usually carry less evidential weight than the primary outcome, especially if there are many of them and no adjustment for multiple comparisons. The more things a study measures, the more likely something will look interesting purely by chance. This doesn't mean secondary outcomes are worthless. They often point toward what future research should investigate. Treat a secondary finding as a lead, not a conclusion. And if a paper's title or abstract emphasizes a secondary outcome more than the primary one, that's worth noticing. The fourth thing you look for is how to read tables and figures. When you open a table, start with the structure, the rows, the columns, the unit of measurement. Once you understand the structure, the numbers become easier to interpret. For frequency distribution tables, look at the shape of the distribution, not just the average. 2 studies can report the same mean value with very different underlying patterns. A mean bone loss of 1 millimeter could mean every patient lost almost exactly 1 millimeter, or it could mean half lost 0 millimeter and half lost 2 millimeters. The frequency table reveals which story is true. The average alone hides it. For graphs, identify the axes before the data. Is the y-axis starting at 0, or has it been truncated? A bar chart with a y-axis starting at 90% can make a 2% difference look dramatic. The same data starting at 0% would look nearly flat. Tables and figures often hold more precision than the rounded summary sentence in the abstract ever shows you. The fifth thing you look for is what's missing. Go back to the methods and list every outcome the authors said they would measure. Then check the results against that list. If the methods describes 5 parameters but the results only reports 4, the missing outcome may raise concern for selective outcome reporting, especially if it was promised in the methods but not fully reported in the results. Also check whether the results reports outcomes for the full original sample or only for those who completed the study. And notice the order in which results are presented. Authors typically lead with their strongest finding. A result buried mid-paragraph, described briefly, may simply be less central to the story the authors chose to tell. By the end of the results section, you should be able to answer 4 questions. How many participants were in the final analysis, and what happened to everyone else? What was the primary outcome, and what exact number answers it? What do the tables and figures show beyond the abstract summary? And is there anything the methods promise that the results doesn't fully deliver? The results section doesn't argue. It shows you the evidence, number by number. Your job is to read every number carefully enough to know what you're actually being shown before the discussion tells you what to think about it. Next episode, we open the actual results section of Booser 2012 and apply every one of these 5 elements to the real tables, the real figures, and the real numbers. Episode 8, The Results Applied to a Real Study. How to read a scientific paper. Dental depth.